All right, so we are off and running with number 7. Number 7 says if the same beautiful swan were to have a ground speed of 3 meters per second and a course of 270 in the same beautiful river, what should be its heading and speed through the water? All right, so let me think about that one for a minute because I want to be sure I know what they're asking. Okay, so what they're asking you on number 7 is, here's what my swan needs to do. So that has to be my resultant. It has to be 3 meters per second headed to the south. The river is still doing this. Oops, sorry, that's a pretty crummy line. Let's see if we can erase that. The river is still headed to the west, like that. All right, so if that's my resultant, then he's going to have to head out like that so that the river will push him that way. That's the river. And this is what he must do, or what the swan must do. Okay, so let me explain this a little bit more. If I want this to be the result and I want him to head south, if he just heads south, the river's going to push him that way and he's going to wind up over here. So he's going to have to allow for that pushing of the river and accomplish a greater speed this way so that by the time the river's finished doing its job on him, he winds up here. All right? So it's kind of like if you're a pilot in an airplane. If you head into the wind, so let's say the wind is blowing like that, and you need to go a certain destination. If you just head out like that, the wind's going to blow and push you off course in that direction. So you have to allow for that. All right? So you have to plot your course, figure out what you need to do, and then head in a direction that will allow you to be pushed by the wind and achieve your result. So the same thing happens with the swan down here. The swan heads out like this so that the river can push him, and by the time the river's finished pushing on him, he'll be south at 3 meters per second. So this is my resultant, and this is my hypotenuse. That's what I'm looking for. So I'm going to say c squared equals a squared plus b squared. So c squared is what I'm looking for, is equal to 3 plus 3. So c is the square root of 18. And when you do that, you get the 4.2 meters per second that they're asking you to find. This angle, if this is 3 and this is 3, this has to be a 45-degree angle. If this is 270, then this is 315 over here. Okay, and hopefully I've talked about pilot's bearing here, 0, 90. Oh, what did I do? Some days I know what I'm doing, some days I don't. Okay, 0, 90, 180, 270, and then I'm back at 0 or 360. So you're just doing quadrant 1, 2, 3, 4, just like you learned in math, and anything in quadrant 1 has a direction of 0 to 90 degrees. Quadrant 2 goes from 90 to 180. Quadrant 3 goes from 180 to 270, and then quadrant 4 goes from 270 to 360. So the swan is over here in this quadrant. He's going to float out like that. The river's going to shove him this way, and he's going to wind up heading due south. Okay? All right, so I'm going to stop for a minute and get the next one pulled up. All right, so now I'm on page 2, and it says, given this vector, figure out the components. All right? Let's see if that's right. Make a well-labeled sketch of the vector and find its components. Okay, so 96 meters per second, 97 degrees bearing. 97 degrees bearing would be in quadrant 2. So this right here, this right here, and yours should look a lot nicer than mine. This is pretty crummy, but you can figure it out. Okay, if this is at 97 degrees bearing, then this angle right here is 83 degrees. Or, if I don't want to do it that way, I can look at it here and here. And there's the 7 degrees. So I'm going to know that the size, magnitude of this vector is 96 meters per second. So if I want the westerly component, westerly component, I can say cosine of 83 times the hypotenuse Or I could also say sine of 7 times the hypotenuse. Either one of those would work. Then if I want the northerly component, I can say cosine of 7 degrees times 96. Or if I don't want to do it that way, I can say sine of 83 degrees times 96. So make yours pretty and do a good job on that one because it's not very hard. Alright. Then we go to number 2. Given the components, find the vector. Make a well-labeled sketch, blah, blah, blah. So dx and dy. So dx looks like, oh, I can't tell if that's 70.1 or 701. I'm going to go with 701. Okay, so dx is 701, and it's to the, it's positive, so I'm going to assume it's to the right. So there's my 701. Here's my dy, it's negative, so it's pointing to the south, it's 63. Then you're going to do your Pythagorean theorem and find this line and find this angle. And you're going to say this is so many degrees south of east. Because to get here, you had to find the east and go south of that to arrive at this point. So that should not be a big deal. Okay, adding vectors. Example, you go hiking, blah, blah, blah. Okay. What is your resultant displacement? So let's take a look at that. Well, okay. So I'm going to go 25 kilometers in a direction of 60 degrees. So I'm going to draw that. Here's my 60 degree, because here's 0, so that would be 60. And that's 25 kilometers, so there's the first one. The second one is 15 kilometers, 135. 135 would be over here in this quadrant. That would be 15 kilometers. And that's 45 degrees, because from 180 to 135 is 45 degrees. Okay, I tell my kids to make an XY chart. I'm not sure what your teacher's going to want. And then I tell them here's an X and here's a Y. They're both positive because you're in quadrant 1, so put those in your chart. Here's an X, here's a Y. This is a negative X and a positive Y. And then I tell them show your work because it's very easy to make a mistake, and I can give you partial credit if I can follow your work. Okay, so this one we'll do first. So we're going to say sine of 60 degrees times 25 kilometers is equal to our Y, and then cosine of 60 degrees times 25 kilometers is equal to our X. So I punch those in the calculator. So I'm going to do sine of 60 degrees times 25, and I got 21.65 for my X. And that means that this is 12.5. And they're both positive, so I'm going to write those down. Alright, then my X and Y are going to be equal because it's a 45, 45, 90 triangle. So X equals Y equals cosine of 45 degrees times 15. So cosine of 45 is 40.7071. Multiply that by 15 and you get 10.61. So remember that this is a negative 10.61 because it's to the west. This is a positive 10.61 kilometers because it's to the north. So this is going to be 32.26 kilometers. And then this minus this, 12.5, minus my 10.61, gives me 1.89. Now look at that and see if it makes any sense. These are going to add together because they're in the same direction, so you should have a large value here. Bingo, we do. These are going to be in opposite directions, so they're going to subtract, so you should have a small. Makes sense. This is a positive, so my resultant is going to be a little bitty x, 1.89 kilometers. A great big y. Pythagorean theorem will give me my resultant. And then that angle, tangent of theta, is going to be very large, 2.26 kilometers on top and 1.89 little small kilometers on the bottom. get your angle. So 32.26 divided by 1.89. Second tan, second answer. 86.64 degrees, which makes complete sense because that's the angle that is north of east. And your motion is all pretty much north. You don't have much to the east, so that should make sense. All right. Okay, a boat is traveling north directly across the river 5 kilometers across. The current is to the east at 5 kilometers per hour. The boat can travel 5 kilometers an hour. What is the resultant velocity? How far down the bank does it drift before it reaches the far side? So I think that this is what it's telling us. Here's a river. There's the shores. It's 5 kilometers from here to here. All right, so the boat heads out that way. The river flows that way. So here's the boat's actual velocity. So I'm going to say 5 squared is 25. 3 squared is 9. So C is going to be the square root of 34. So that'll be the speed of the boat. All right. And then they want to know how far down the bank does it drift. Well, here's what I know. If this is 5 kilometers and my speed that way is 5 kilometers per hour, I'm going to go this way for 1 hour, this way for 1 hour, and this way for 1 hour. So it should be 3 kilometers downstream and 5 kilometers across the river. And then you could find this whole value right there if they wanted you to find that. That would be down the stream and across. So I'm not sure that you need that, but that's what you would do. All right. Hope I've been some help.